Hello students, once again this side Priyanka Mehta, working as an assistant professor in Computer Science and Engineering Department of Sangam University, Bhilwara, Rajasthan. In my today video, I'll be discussing in detail about cache memory. In all my previous video, I have already discussed about the memory organization, the hierarchical structure of memory, as well as I discussed about main memory in detail. Now in my today's video, I'll be focusing on cache memory, why cache memory is used within a computer system, as well as I will also discuss about the performance of cache memory. Okay, so let's start with this. Students, let me first explain to you all that what is a cache memory. Well, as you all know that a cache memory is a very special type of memory which is extremely small and extremely fast, and it is placed between the main memory and the CPU. Now here in this diagram you can clearly see that between the processor and your primary memory, that is your RAM memory, we have a very small size memory which is placed between them, and this memory is known as a cache memory. Now let us first understand that why this cache memory is needed between the processor and the main memory. Well, the answer to this question is to reduce the average access time of the main memory. So I asked you a question that why this cache memory is used between CPU and main memory. Well, the answer to this question is to simply reduce the average access time of the main memory. Well, what do you understand by average access time? Well, an average access time, or in a simple words, if I say an access time is a time which is required by a processor to read a piece of information or data from the memory. Alright, now in order to reduce the average access time of the main memory, that is the time required to read a data from the main memory, if somehow I want to reduce it, this memory can be used in order to reduce this average access time. Alright, now let's see that how it can be accomplished. So how I can reduce my overall average access time of the main memory. Now just by keeping my cache memory very small and storing the copies of data from main memory which are frequently requested. So if I need to reduce my average memory access time of the main memory, what we can do that we can place a very small size memory which is storing the copies of data from the main memory which are frequently requested. So those data which are requested frequently, we can place a copy of that data into the cache memory. Now this will ultimately reduce the average access time of the main memory, as now the data and instructions can be immediately made available to the high-speed CPU from the cache memory. See, as we all know that main memory size or its capacity is slightly larger than the cache memory. Alright, now in order to search a data from the main memory, the time required to search a data from main memory will be larger as compared to the cache memory, because cache memory is small in size. So basically what we are doing here, whatever data which is frequently requested, we are having a copy of all that data and it is copied into the cache memory so that any future references comes, then the data can be directly read from the cache memory instead of reading it from the main memory. So this is the reason we are having this small size cache memory between the CPU and the main memory. Now let us understand that what is the working principle of the cache memory. Well, cache memory works on the principle of locality of reference. So let us understand that what is it. Well, it has been shown that analysis of large number of programs, they have shown that the references to memory at any given interval of time, they tend to confined within a few localized areas in memory. It means that a locality of reference is a phenomena in which the processor tends to access same set of memory locations or same portions of memory locations repeatedly over a short period of time. So those memory locations which are repeatedly referred by the processors, they become the localized areas, and hence we call it a locality of reference. Now, the property of locality of reference is mainly shown in loops and subroutine calls. Now, especially in case of loops, as we all know, a loop is some set of statements which are repeatedly executed. So, especially in case of loops, the CPU repeatedly refers to set of instructions in memory that make up a loop or that constitute a loop. Also, in case of subroutine calls, the CPU also repeatedly fetch the set of instructions from the memory every time a function or a subroutine is called. So these are the two cases wherein we can see that a CPU is making continuously some references to the memory, and those references are repeated references, all right? Now, the result of all these observations is the locality of reference, which states that over a short interval of time, the addresses which are generated by a typical program, they try to refer to few localized areas of memory repeatedly, while the remainder of the memory is accessed infrequently. So there are some portion of memory which are frequently accessed and some portion of memory which are accessed very infrequently. Hence, if we place some active portions of the program or data in a fast small size memory called as cache memory, then definitely we can reduce the average memory access time, and thus it will help you to reduce the total execution time of the program. So this is the major objective of using a cache memory between the main memory as well as between the CPU. Now let us understand the basic operation of cache. I guess it will give you a more clear idea that how this locality of reference works. Now whenever a CPU needs to access memory, or you can say that whenever a CPU needs to or request some data to be read from the memory, in that particular case the initial memory which will be examined by CPU will be the cache memory. So first of all, CPU is going to search that particular data from the cache memory rather searching it from the main memory. Now, if the data is found in the cache memory, then it is read from this particular memory. But what if this data does not exist in the cache memory? In that case, the CPU is going to access the main memory. So if the data addressed by the CPU is not found in the cache memory, in that case the main memory is accessed to read the data. Also, after reading the data from the main memory, those data or those block of words, memory words containing that data will be transferred or will be copied or will be mapped from main memory to cache memory. So why this data is copied from main memory to cache memory? As I have already said that just in case in near future, if such memory references comes again or CPU wants to read these data again, then in that case, rather reading that word from the main memory, it will be directly read from the cache memory. So in this manner, some data are transferred to cache so that any future references to memory can be find the required words in this fast cache memory. Now let us first understand the performance of the cache memory. Well, the performance of cache memory is frequently measured in terms of a quantity which is called as hit ratio. Now let us understand what is that. Now whenever the CPU refer the memory and it finds the data in cache, then it is said to produce a hit. So whenever CPU examines initially the cache memory and if the CPU is able to search the data, in that case we will say that there is a cache hit. Now if the data is not found in the cache, then obviously that data is into the main memory and hence we call it a miss, a cache miss. Thus the ratio of the number of hits divided by the total CPU memory references, that is hits as well as misses, will give you a hit ratio. So naturally, if the hit ratio is high enough, and it means that most of the time the CPU is accessing the cache memory instead of accessing the main memory. Hence, the average access time is quite closer to the access time of the fast cache memory. So definitely, in order to improve the performance or efficiency of your computer system, we would want that a processor should make access of cache memory more frequently as compared to the main memory. So if the hit ratio is high enough, in that case, it means that most of the time the CPU is accessing the cache memory. Now, as it is clear from the diagram, you can see that initially, whenever a CPU needs to read some data, it will first of all examine the cache memory. If the data is searched successfully from the cache memory, then the data is read and we call it a cache hit. But if the data is not available in the cache memory, in that case, the CPU is now going to search that data from the main memory. And after searching from the main memory, it will read that data from the main memory. Also, the data will be copied from main memory into the cache memory. This has been done because just in case if processor needs to access the same data in near future, then that data can now be directly read from the cache memory rather reading it from the main memory. So I'll discuss some short definitions which will give you a brief idea what we have discussed till now. So let us understand what is a cache hit. A cache hit occurs if the requested data is found in the cache memory. So if the data is available in the cache memory, in that case, we are simply going to say that there is a cache hit. Now, let us understand the next term, that is cache hit time, which is denoted by small t, and in a subscript, we have a small h. Now, in case of cache hit, the time required to read the data from the cache memory and delivering it to the CPU is called the cache hit time. So if the data is available in the cache memory, so definitely your processor would require some time to search that data from the cache memory and finally reading it. So that amount of time will be termed as cache hit time. Next is cache miss. A cache miss occurs if the requested data is not available in the cache memory. So we call it a cache miss. Correspondingly, we have another term, that is cache miss time. So definitely if your data is not available in the cache memory, then in that case the data has to be read from the main memory. Alright, hence the time required to read the required data from the main memory is called as cache miss time. Next we have hit ratio and miss ratio. Well, hit ratio can be defined by the following formula. It is given by the number of cache hits divided by the total number of memory references. So total number of memory references means the number of cache hits plus the number of cache misses. So from the denominator, it is quite clear that number of cache hits means when the data is read from the cache memory, plus the number of cache misses means the data is not available in the cache memory, but now the data is read from the main memory. Hence, in the denominator, we have the total number of memory references made by the processor. Similarly, the miss ratio can be given by 1 minus h, that is 1 minus hit ratio, and it is given as the number of cache misses in the and divided by we have number of cache hits plus number of cache misses, that is the total number of memory references. Next we have the average memory access time. So previously whatever components I have discussed, let's understand all those components once again and we'll try to recreate the formula for the average memory access time. So it is the average time required by the CPU to read the data. So a memory access time or an average memory access time is the time which is required by a CPU to read the data from the memory. Now whether it reads the cache memory or it reads the main memory will count as a memory access. Alright, now its formula is given by TA. Now TA here denotes that average memory access time, which is equals to, now here we have two components. The first component is H multiplied by TC. Now the first component says that whenever the CPU examines the cache memory, and if the word or if the data is available in the cache memory, in that case the data is read from the cache memory. Hence we have two components here. Hit ratio is multiplied by the cache hit time. Cache hit time, the time required to read the data from the cache memory. Plus we have another component. Now why we have added this second component? Just in case if the data is not available in the cache memory, in that case the data will be read from the main memory. Hence in the second component we are multiplying two more components, that is miss ratio, which is given by 1 minus h, and it is multiplied by cache hit time plus cache miss time. Cache hit time because the time required to search a data from the cache memory, but the data was not found, and now the data will be searched from the main memory. Hence we are adding both these components, that is cache hit time plus cache miss time. So this total quantity will give you the average memory access time. So this formula might be helpful for you all in solving some of the numericals related to the cache performance. Thank you so much students for watching this video. Students, if you have any questions related to this topic, you can drop your queries on my mail ID. My mail ID is priyanka.mehta@sangamuniversity.ac.in. Please like my video and subscribe for my channel. Thank you so much and have a nice day.